thing I'll do is just share the link. Oh, we are live. Okay, cool. I'm just going to send the link to my people so they can post it more places. And we already have 4 people tune in. Okay.
You can just send me the link too if you want. I can share it.
Sure. Yeah. I'll send it to you in the chat here. And hello to everyone who is already tuning in. We're just getting started in like 20 seconds. I need to learn how to do the intro video feature, but and I can maybe even
Again.
Nice. Getting people to see this. We will also have a recording of this on YouTube and short clips and stuff that I'll share with you later. But once you've sent it, we'll get rolling. Okay, cool. Well, thank you to everyone who's tuning in so far. Thank you for joining us for another Wednesday community call / Aligned and Friends. This series is basically, sometimes we have updates, sometimes we bring people from our developer community, and sometimes we have great guests like Paul Henry over here from Miden, joining us to blow our minds about interesting ZK stuff and just teach us about the cool things they're working on, get the ideas flowing for people who want to build using ZK. So Paul Henry, welcome. It's nice to see you.
Yeah, thank you very much, man. I'm glad to see you too.
So actually, before we dig into Miden, I really would like to hear you tell us about your background. I've heard it before, and I think you have a great pinned tweet, but your story is awesome, and I think a lot of people would be interested in hearing how you got to where you are today and the different things you worked on that brought you here.
Yeah, that's actually pretty funny. I think I have a pretty original background. It's not a traditional journey of like just maybe going to school for software engineering and then maybe going into a company. Have something a little bit weirder, but I think that is also the richness of it that I definitely derive value from. So just to make it very short, I'm French. I'm from Paris, but I lived also when I was younger in Singapore for a few years. Came back to Paris after that. Very luckily, I learned English there, which I think is one of the most valuable skills that anybody can have nowadays. And then I came back. I started playing in soccer a lot. So I started playing in a small team next to my house, and then I got recruited by PSG, so Paris Saint-Germain, which is the biggest French team, and I played there for about 10 years, from like 8 to 18 or 8 to 19 or something like that.
In their academy team?
Yeah, exactly.
Yeah, cool.
So I played there for a bit, and then I traveled to many countries for football and stuff like that, and at one point I got to professional level, so I signed my first professional contract, and the funny story with that is that like a few days after signing my pro contract, COVID hit. So that was funny. So my contract got canceled, and then I didn't really know what to do with my life, because I didn't really have a contract anymore. There was COVID. It was really hard to find another contract. And then after a year of continuing to train like 2-3 times a day, every single day during COVID, I just didn't want to do it anymore. I didn't like it anymore. I was bored. I wanted to do other things, and I thought that I also had the opportunity to do other things. And so I was just like, fuck it, what should I do? And I found programming, and I just banged my head like 15 hours a day against my keyboard until I kind of got the gist of it. And then I learned programming like this, mostly online. So on Udemy, in books, and online courses from MIT and stuff like that.
Just doing your own side projects and experimenting with things, teaching yourself.
Yeah, exactly. I think we're extremely lucky nowadays. Like resources are available. Like anything you want to learn, you can. Like you want to learn rocket science, you can fucking learn rocket science on the internet. Like, and this is incredible. And I think that if you want to do something, you can do it. And that's the beauty. It's like it will take a lot of energy. It will take a lot of time. It took me more than a year, banging my head every single day, hours on end, and people thought I was crazy. And one, I didn't have anything to do, and two, I needed to find a new passion because I didn't have an identity anymore. Like the soccer Paul Henry was not here anymore. So what should I do? And so I really, really wanted to find something else, and I put the time and energy, and it kind of paid off. And so, to go really quick, I traveled, I made my own company doing service, like doing just programming for different companies, and then got into crypto, started learning about crypto, going a little bit on stage, talking about crypto to people, like teaching people about crypto. I was living in Indonesia at the time, and then started working a little bit on open source projects. Then started working with Starknet and Starkware on the implementation of light clients. Worked a lot on that, and then led the team that was implementing the light clients on Starknet at the time, called Boris, about 2 years ago. And then started working with the Ethereum Foundation during a fellowship, also in collaboration with Lambda class, building a new consensus client in Elixir, and then got recruited by Polygon and Miden to work on what we're mostly going to talk about today. So it was a pretty crazy journey, but some fun stuff. Yeah.
That's awesome. I feel like crypto does have more of these like atypical career paths than maybe other sectors within tech. That's at least what I seem to have noticed, and it's funny. You know, I know your story, and thank you for sharing it again. That's awesome. You can actually just do things, and if you're passionate about it, you know, you will find a way to make some big contributions. Like I talked to some students who are in university right now studying computer science or engineering, and you know, there's people like you or like Philip, others who either dropped out of university, self-taught, who are really making big contributions to like blockchain engineering, zk stuff. And it's, yeah, I tell these students, they're like, how do I get into this? I'm like, you just start doing things, do hackathons, learn, tweet about it. You know, you will you will find your way if you want to. So that is awesome.
You can just do things.
You can just do things. Yeah, yeah. The world is permissionless to some extent, which is a good segue into Miden, because I know a bit about Miden. I've read up on it. I've seen some presentations, but I still feel like there's a lot for me to learn, and there's a lot of pieces that excite me a lot about what Miden is doing. So I feel like the best way to get into this is just to let you. I know you have the pitch down, so I think I just need to hear it.
For sure. So just to give you maybe the TLDR, so Miden is we have different capabilities, but basically it's layer 2, built on top of Ethereum, or could be built on top of anything, but it's mostly follows the architecture of a layer 2 right now. The idea is that we're using zero knowledge, so mostly Starks, like uniquely Starks. And we built this zkVM that was called the Dista VM, and that's called now the Miden VM. And basically, the idea of this virtual machine is to be able to execute arbitrary code and to be able to generate proof that this code has been correctly executed. What is interesting with this VM and with the prover and the verifier that we have is that we also we're adding it right now, and it's almost done, but it's also fully zero knowledge, because you have mostly like two components to zk, which are the succinctness, so the effect of compression, where you're going to take a large amount of computation that you do off chain, you're going to prove that the execution of that was correct, and then you're going to settle this proof on Ethereum. So you're going to derive security from that, but you're not really going to derive any privacy, because you can still look into the proof, look into the inputs and stuff like that, and kind of get get some information from that. And most proof systems are implemented today. But what you can do is really also leverage the zero knowledge properties of zero knowledge. But this takes additional work that you need to do to be able to obfuscate all the information. And so Miden gives you this out of the box. And so that's the first thing. So we're layer 2 using a zkVM on top of Ethereum, and then I can talk to you about all the very, very cool capabilities that we can do on top of that. But
Yeah.
I saw that maybe you had a question.
Well, I just wanted to make sure I'm following correctly. I think you summarized it really well, but it's layer 2 for Ethereum. You have your own Stark-based zkVM that allows you to do arbitrary computation on your rollup. You're getting security from Ethereum, but there's this part that I think you're going to tell me about right now, which is the privacy aspect of zk, which most zk rollups are not giving you. They're really relying on the succinctness property for scaling blockchains, but they're more like they should actually be called validity rollups. Whereas it sounds like Miden is actually a zk rollup.
Exactly, and I think that it will be actually the first zk, like true zk rollup, at least that we're going to see. And I think it's going to unlock a lot of things, and I think that it's going to be very interesting. But I just wanted to start with the zkVM part, and explain that it's also actually private, because I know, and mostly the audience maybe have a little bit more understanding of it. But to give you really the exciting pitch about Miden, basically the idea is that what we do is that we push computation to the edges. So instead of having the Ethereum model where you have computation on chain that is re-executed by all the nodes of the network, instead of having a zk rollup, let's say Starknet, for example, where you still have users that make transactions that send them to the network, and then the network execute these transactions and then generates a proof of validity, as you said, a validity rollup, and then settles this proof on Ethereum. What we do is that we have what we call client-side proving. So instead of the network doing the execution, you have all the users doing the execution, which means that you're not bounded anymore. You don't have to pay gas on the amount of code that you're actually executing. So you can make arbitrary complex transactions because you're computing on your machine. And this gives you multiple things. And the 3 main components that it gives you is, first, security. Because you can have your accounts state, off-chain, and local, and you're executing locally using the Miden VM and the Miden prover on your computer or on your phone, etc. It's a lot more secure, because how is a hacker going to hack a contract that is not on-chain? The only thing that you have about the contract on-chain is a commitment to the contract, commitment to the state, but it's not the actual contract. So it's a lot more secure because a hacker cannot hack something that he doesn't see. So that's the first thing. The second thing is the scalability aspect. For 2 things. The first one is unbounded execution. You can do AI inference. You can do extremely heavy computation, and be able to do that off-chain on your machine, and still be able to send a commitment like with the proof that the execution of this extremely heavy computation was done correctly off-chain. And so you don't need to pay relative to the amount of computation that you're doing anymore. And so it's a lot cheaper off-chain, so locally, but it's also a lot cheaper on-chain, because it means that the network, instead of having to compute a lot of things, the chain is only verifying stuff. So Miden, the node, the operators, the only thing that they're doing, actually, they're doing multiple things, but it's more of a verification rollup, where what the network is doing is actually verifying the proofs of the users, aggregating these proofs together, and then aggregating that into a final proof that we're going to send to Ethereum. So it's more of a verification rollup than an execution rollup.
That is super interesting. I want to ask about a couple things you mentioned so far before you continue, just so we don't get lost here. So when people typically think of a ZK rollup, it is some centralized sequencer or maybe a network, some shared sequencer, ordering transactions, basically doing all the transactions off chain, but then posting the results to Ethereum using a zero knowledge proof. Miden also does that, but there's another layer to it where each user is creating proofs and then sending them to Miden, and then Miden is pulling those all together, verifying them, and then making a new proof, which goes to Ethereum. Exactly. So it's like every user becomes their own sequencer in a way. I don't know if that's a good analogy, but that's how I'm interpreting this.
Yeah. If you had to make an analogy with like regular blockchains, that would be the idea. Is like each user becomes their own sequencer in a way because they're doing their own execution and proving. And so we have this very optimized prover, this very optimized zkVM that enables you to do that. Before, it wasn't really possible to do client-side proving and execution because we didn't have the amounts of optimization necessary to be able to do them. It was way too heavy, was way too slow. We needed some specific like hardware, like ASICs or what, to be able to run and generate these proofs and to execute this computation in these previous zkVMs, but not anymore. And so the last thing also that this gives you, and I think one of the most interesting, is that because you have your state locally, the state is not stored on the chain. There's only a commitment to the state that is stored on chain, or you can do it multiple ways, but one of the ways is because you store a commitment on chain of your account, but you have the state of your account locally, you're executing locally, you're proving locally, and you're sending this to the chain to validate the fact that you did a local state transition that is valid. You can get privacy, which means that Miden can be a fully private chain. So you can do public transactions, but you can also do fully private transactions. And this is incredible. This is super, super interesting. And the reason for that is just that I have my state locally. I can use the Miden VM locally on my machine to transition my state. I can generate a proof of this valid state transition. And then all the outputs of my VM, so my new states, we have also concepts of nodes and nullifiers and the proof. I can take all of that and all the sensitive data, instead of sending it directly to the chain, I can hash it and then send the hashed outputs to the chain. And so the chain, thanks to the proof, can still verify the fact that your state transition was valid, that what you did locally was valid on your machine, on your phone, or your computer, whatever, but doesn't need to see. And so, which means that you can make things fully private. So on Miden, you can own things privately, you can execute smart contracts privately, you can make private transfers, you can do all these things. You can trade privately, everything that is DeFi related, you can do privately. So these are the three main components of Miden, or the three main value proposition, in my opinion. It's like a lot more security, a lot more scalability, and a lot more privacy. And so these are, in my opinion, the three reasons why Miden will become just the best blockchain that has ever been built.
That's awesome. I mean, so we have this new way of looking at things where every user is their own blockchain, almost. And yeah, so I have a bunch of questions because as you were describing all these great features, I just started thinking like, well, what about this? And how do you deal with this problem? And like, I think an easy spot to start is hardware, because we're talking about client-side proving. You said a user can do this on their phone, on their laptop. I'm curious to hear how much, what kind of resources somebody actually needs to do this. Like, will this run on my iPhone? And will I be able to do super, like, would I be limited in terms of what computation I can do if I have a weaker device, for example? Like, could I would need to maybe use somebody else's computer or some service to do some things, but like, how do you approach that?
Yeah, very good question. So I'll answer in multiple ways. The first one is giving you what we have right now, which is right now you can generate a proof on a MacBook Pro, for example, what I have right now, in less than a second or 1 second, 2 seconds maximum. And so with proof for a transaction, a proof for some computation. Then the more complex the computation is, obviously the larger the time for execution improving. But for simple things like transfers and stuff like that, it can take less than a second or 1 second, around 1 second right now. And so this is already very fast. And just keep in mind that this is the worst that will ever be. We can only go lower from there. Because zk is getting faster every single day. We're making new findings in zk research, which makes it even more optimized. Also, computers and phones are getting better and better. Like, look at the M series of MacBooks and stuff like that. Like, so it's incredible to think that it's also already usable, but it's only going to get better. So that's the first thing on the computer. On the phone, you have a more constrained environment. So you have less RAM, you have less CPU power, you sometimes have no GPU or low GPU power. So it's harder to do on a phone than on a computer, for sure. Now it's still pretty fast. Like, even on a phone, like on an iPhone 16 or something like that, it would be a few seconds, like 5 seconds to 10 seconds maximum.
Still
So
plenty fast.
Yeah, it's still usable. It's still a good user experience. Okay, maybe I don't want to wait 5 or 10 seconds. Maybe if I use Revolut, my transfer is validated in 2 seconds. Okay, so how can we get there? Then maybe we'll not get there right now, but maybe in 1 year, 2 years, 3 years, we'll be there. And we'll have a lot more security, a lot more features, but the same UX as something like a bank app that we use nowadays. So yeah, just to clarify, it's already usable.
Okay.
Right now. You can even test it in testnet. It's already it already works and stuff, and it's only going to get better. So that's the thing. Now, obviously, the worst phone you have, the slower it's going to be. So if I have an iPhone 16 Pro, then it's going to be pretty fast because it's a very powerful phone. But then if I buy a $50 smartphone that has a very old chip from 2015, then obviously it's going to be a lot slower. And so what do you do in this case? And so in this case, we have thought of different ways, but one of them could be delegated proving. So the execution is not that expensive. What is usually pretty expensive is also the proving. And so to make sure that everybody can execute and generate proofs in a very good amount of time, what you can do is, for most transactions, or for some transactions where you don't actually need privacy, you can compute locally in a few hundreds of milliseconds, for example. Take the output of the computation, send this output to a delegated prover, which is a specialized machine that we could or other operators could run with some specialized hardware. And this machine will generate a proof extremely fast for you and will submit the transaction for you on chain. And so basically you said, okay, I don't need privacy, but I got this from my phone, which is a $50 phone. I got a proof generated and executed, etc., in like 2 seconds. And so I think it's a very good trade-off that we can make, because what we want actually is not like a super cypherpunk vision, etc. What we want is flexibility. What we want is usability. So if you need public transactions, you can do them. If you want private transactions, you can do them. If you want very fast transactions because you still have a bad phone, you can do them. If you accept to have a bad phone and really want privacy, you can do that, but you'll wait a little bit more. So it's just giving flexibility to people to build an ecosystem that is usable, and we can get into that later, but where we can really see real world use cases and real world apps get built on Miden.
I love that, and I'm definitely going to ask you about the ecosystem, the developer ecosystem, what you've been focusing on lately with your new role leading DevRel, I believe. So yeah, I want to get to that in a second, but there's still some technical things that I'm really interested in hearing. So what I am curious about is how you approach composability and the problem of not sharing the same state across all the users of Miden. If everybody has their own private local state, well, there's one thing, like what happens if that state is lost? If you lose your phone or your access to it, I mean, I feel like this is just like a private key thing. If you have your private key, you should be okay. But I mean, if there's actual data that needs to be accessed, right? Not like just the commitment to the data is not enough. What happens, right? What if someone loses their phone or they don't have a backup? Is there an easy way to have backups? And how do you do things with other users? Like, I don't know, would a lending protocol be its own user in this case? Or would it have to be hosted by somebody who's always live so you can always interact with them? Is there a hit to synchronous composability or not? Is this necessary? Curious to hear.
Yeah, very, very good questions. So to answer the first question regarding state. So there's one burden that we put on people nowadays in the crypto ecosystem, which is the private key, as you said. It's like if you want to be sovereign, then you need to have your private and public key pair. So you need to store these 12 words or these 24 words, etc. On Miden, you have the possibility to have private state, which means or you can store all your state locally and only put a commitment to your state on chain, or you can have regular accounts, have a fully on-chain account, exactly like on Ethereum or any other blockchain, and then everything will be handled there. So if you have a public account, then nobody will be afraid. Even if you lose, you have nothing to lose. I mean, you still have your private public key pair, but nothing changes from the regular architecture of blockchains. If you have a private account, now you also have the state that you need to store locally. But you already have like a public and private key. So what you can do with this, you can even decide to, for example, encrypt this state and store it somewhere. So I encrypt this state and I store it in Google Drive. I encrypt this state and I store it in iCloud Drive. I encrypt this state and I keep it in my browser. My browser wallet, my Miden wallet will have something that automatically stores your state and stuff like that. So there's many ways that we can make sure that you don't lose your state. So yes, you need to store the state, but actually it's quite a trivial problem to find a solution to, because we have easy ways of encrypting it and storing it in some places. So even if you lose your state, it can be automatically backed up, for example, on every transactions by your wallet, and your wallet has a service that if you change computers or if you lose your computer, they can give you back your state. You just need to not lose your public and private key, I guess, but that's every blockchain.
Yeah, but now we have things like social recovery and account abstraction, which can make a lot of those user experience problems, a thing of the past.
Exactly.
So actually, how big is the state that one would need to store? Like, how heavy are we talking? Like the actual size, and do you have ideas about how this will grow over time or not? Are there ways to prune it and keep it small, or will you just, is it not an issue at all?
I don't really think that it's an issue, because storage gets cheaper and cheaper. And the type of the type of data that you would store in an account is not that much when you think about a smart contract, or when you think about like accounts that we have on Ethereum and stuff. They're usually pretty small. We're talking kilobytes or megabytes. But even if you wanted, you could have an account of 10 gigabytes on Miden now, because your account is not stored in chain. So it's not expensive to have high amounts of storage anymore. So if you have an off-chain account, then you could have like like gigabytes of storage or terabytes of storage if you want. But the regular account would be like kilobytes or megabytes. So it's something that is trivial to store. So that's the answer to the problem of storing state, which I think is not really a problem. Regarding composability, basically what we have in Miden, we're using what we call the actor model. The actor model, meaning that you have different actors in a system that have inboxes and that send messages to each other, and each of them have their own state. So they're state machines, they keep their own state. And to change your state, you will receive a message, process this message, modify your state, and then you can send other messages to other people. And how is this implemented in Miden? We use what we call nodes and nullifiers. And this is one way of implementing local transaction execution, local proving, and privacy in blockchains. You can find it in multiple blockchains. This idea of like nodes and nullifiers. You can find it in Aztec, you can find it in Alio, you can find it in many privacy preserving protocols. And the idea is that if you want to be able to implement privacy, you also need to break what we call linkability. And why? Because you need to be able to break the link between two accounts. You don't want, if I send you money, there's a link between us two. And why is there a link between us two? Is because accounts in most blockchains are atomically modified. What do I mean?
Yep.
Is that in Ethereum, if I want to send you money, then I take my private key, I generate a message, I sign this message with my private key, and then I send this message to the chain. And then what the chain will do, it will verify that my message has actually been signed by my private key. And then it will receive this message in the mempool, validate it, put it in a block, execute it, and decrease my balance and increase your balance atomically. Oh, I see that you froze. Are you still here, Boris? Oh, I don't know if Boris is still here. I think I was talking about atomicity of blockchains and he got bored.
Hello. Oh, I think my Wi-Fi dropped for a second. Am I back?
Okay. Yeah, you're back. You're back. Yeah, I didn't know I was that boring.
Slight technical issue. Oh,
I hear you now. Do you hear me?
okay. Sorry, everyone. It's kind of garbled, and you're still frozen from my end.
Oh.
This is the first time this has happened on a stream, but let's see.
Unlucky.
Okay. I can hear you. Can you hear me?
Yeah, I can hear you. I can hear you. Is it on my side? Let me see. I can hear you. I don't know if you can hear me. Let me see if we're still live. I think we are. Now I'm alone. So I'm live but alone, I guess. Yeah, I think I was talking about atomicity of blockchains and he got bored and he just left. No, but I can restart my argument when he's back.
I'm back. Okay.
Okay, you're back.
I'm back. Sweet. Yeah, my Wi-Fi was rugging me. Sorry about that. We were talking about nodes and nullifiers ability between accounts.
Yeah, exactly.
Maybe I'm not back.
Okay. Yeah, you're back. You're back. Do you hear me? I see you.
So hold on. I'm going to move closer to the router.
Okay.
Is what I'm going to do. Moving through my house to a stronger Wi-Fi spot.
It happens.
Yeah. Okay. All right. I think we are in business.
Nice. Okay. Do you hear me now?
Loud and clear.
Great. Very cool. Yeah. So just to finish what I was saying, what we want is to break linkability between accounts. I don't want anyone, if I'm trying to build a privacy preserving protocol, to be able to see that I sent money to you directly. So how do we break this link? Considering that most blockchains are usually atomic, which means that there's a link between all the actions that are taken. In the sense that if you see on Ethereum, what happens, I have a public-private key pair, I have an account in Ethereum, I have one ETH. I want to send you one ETH. And what I do, I create a message locally saying, I want to send one ETH to Boris. I sign it with my private key. I take this message, I send it to the chain. The chain receives it in the mempool. The nodes check and validate the fact that it's actually a valid signature, that it's actually my account that wants to spend this one ETH. It adds this transaction into a block. This block is sequenced. This block is validated, and then this block is finalized. And when the transaction is executed, basically what happens is that atomically my balance will be decreased by one ETH, and your balance will be increased by one ETH. And so we can see in this transaction that there's a direct link between both our accounts. But if I don't want to have this link, then what I need to do is that there's one transaction that happens where I transition my state from a state where I have one ETH to a state where I have 0 ETH. So this is what happens in Miden. And then I take a message that we call a note. I send it to you, for example, off-chain. So I can send it to you by mail, or maybe I can encrypt this note on-chain and you can decrypt it and receive it. Or I send it to you by message, or by Signal or Telegram, or whatever. You receive this message, and then you consume this message locally, and you transition your state using this message from a state where you have 0 ETH to a state where you have 1 ETH. And so here, there's two state transitions. We can say that there's two transactions, and there's basically a transaction that decreases my balance, and there's a transaction that increases your balance. But the thing is that these two things were not done atomically. They were done asynchronously. So Miden is fundamentally an asynchronous and concurrent blockchain, where I do something, I send you a message, I do something, I generate a message, I send you this message, you consume this message, and you transition your state. And here we were able to send money to each other, but totally privately, because there's no link between our two accounts. Basically, I did something, and a million other people did something. In between this time, other people did other things, and then you did something, but there's no way to link both of our accounts. And so this is why, and this is also how it works on Miden to fix this question that you have, to answer this question that you have around composability. And then I can get deeper into how it would work with a smart contract. Maybe I'll just finish now and talk to you how it would work with something like, for example, Uniswap. So this was the example of making a peer-to-peer transfer. So I have 1 ETH, I transition my state from a state where I have 1 ETH to a state where I have 0 ETH, I generate a note, I take this note, I send this note to you, and then you consume this note, you transition your state from a state where you have 0 ETH to 1 ETH, and then we made the transaction. There's no way to link both of our accounts, private peer-to-peer transfer. Now, if I want to execute a swap, for example, what I need is public shared state. So I need a contract that is on the blockchain that multiple people can interact with. And so we can also do that on Miden, because it's a very, very flexible protocol. So I can have a private account, I can have a public account. And if I create a public account, this public account will be a smart contract. And on the smart contract, I can create the logic of Uniswap. And basically what will happen is that privately, I can transition my state. For example, I can create a node that is directed to Uniswap. I take my state that has 1 ETH and I want to swap it for 1 BTC. So I will generate a node that has 1 ETH inside there by decreasing my state of 1 ETH. I will send it to the chain saying, I want to execute this node against the Uniswap contract. The Uniswap contract will take this node, will consume this node, and will generate a new node with 1 BTC as an output. And then I will pull down this node and consume it back. And so it took multiple interactions. So it took one state transition, another state transition, and then a third state transition for me to consume back the BTC. But with this, you were able to privately execute a swap against a public contract. And so this is very cool. And there's ways to make it like very, like a good UX and stuff like that, and to obfuscate all of this logic. But basically, you can do pretty much exactly the same things that you would do on a public blockchain on Miden. It's just under the hood, there's a different architecture.
Interesting. You're not using a UTXO model, are you? It's all account based?
We are.
You are using UTXOs, okay.
We are using an account based, we basically call it the hybrid UTXO account based model, which is we have accounts to represent like users, so smart contracts, user wallets, etc. We have full account abstractions. So basically all accounts are smart contracts. So you create a wallet, you're a smart contract. Uniswap creates an account, it's a smart contract. It's all smart contracts. But these smart contracts, they don't interact together atomically through transactions. They interact asynchronously using nodes. And so the nodes are UTXOs, like on Bitcoin, and the accounts are smart contracts, like on Ethereum. And so basically, this gives you the best of both worlds. You have programmability with accounts, and you have privacy using UTXOs. And so you can get the best of both worlds.
Okay, very cool. A lot of features, a lot of different. I think I'll probably need more time to wrap my head around how like a lending protocol like Aave could exist within this architecture. But I think we can maybe save that for another time, because I really want to hear your thoughts on the developer ecosystem and getting people to build on this, challenges you've seen. I mean, you mentioned that you're in testnet now, so I imagine people are already trying things out, deploying apps, but the way that Miden is designed is a little bit different from what most developers probably used to, I'm guessing. So I'd love to hear about the DevRel or ecosystem strategy and how you're thinking about getting people to build all sorts of cool apps using the unique technology that Miden's offering.
Yeah. So as we were discussing a little bit before the call, like I was doing protocol engineering for about a year at Miden, and then I just transitioned to leading the DevRel team now that the team is growing, and I think that it was a role that I was pretty fit for, so I was super excited to do that. And so basically there's a few challenges. One of them is it has a novel architecture. So it has accounts, but it also has nodes and nullifiers. It uses a zero-knowledge virtual machine. The zero-knowledge virtual machine uses an assembly language called Miden assembly. But now we also have a Rust compiler, so a Rust to Miden assembly compiler, which means that you will be able to write your smart contracts in Rust. But so it's a little bit different paradigm. And then you have privacy, and then you have client-side execution, client-side proving. So it's another paradigm that you need to kind of get in your head compared to Ethereum, where it's like on-chain computation, on-chain contract, everything's public, EVM, that I think people took a few years to understand, but now they kind of get the gist of it. With Miden, you have a lot more features, and you have new things. So you need to learn Rust, you need to understand the architecture, you need to understand the value proposition and stuff like that. But I think we're starting to get to do a good job about simplifying that, obfuscating all the details that are not really needed for developers to know, etc., and giving some good abstraction layers on top of Miden for people to be able to use easily. So we have a component that's called the Miden Client, and this is basically a software development kit, so an SDK that all the developers can use to be able to build on Miden. So you just import the Miden client inside your repo, and then it helps you like interact with the blockchain, sync, create transactions, etc. It does pretty much everything for you. And so this is one of the components that we're building for people to be able to interact with the chain. And then we take care of all the rest, like the node, the VM, the crypto, and all the primitives to make the blockchain work. We take care of. So that's that. On the ecosystem side, yeah, so as I told you, we have some challenges, but we're making it better and better. Also, I advise people to go check out our documentation. We just had a new release, so version 0.8. And we have what we call the Miden book. So in the Miden book, you have everything you need to know about Miden, the documentation about the protocol, the VM, the node, the compiler, the client, the tutorials to how to use the blockchain, how to make smart contracts, everything. So that's really cool. I really advise people, if you're interested about all of these things that we've talked about, to go check it out. And so that's a very good resource now. Um, and basically, how is it to build this developer ecosystem? My vision is that Miden will really, really bring something new. Like it will be a new paradigm. And the reason for that is that it brings some things that are extremely interesting for companies. And these two things are, or these three things are, it's cheap. So it's cost efficient for companies. It's secure because you can have these off-chain contracts and this off-chain logic, which makes it extremely hard to hack. And it's private. And so these three components are three things that companies really, really needed and that was not present on Bitcoin or Ethereum or stuff like that, or other blockchains that got created after that. And so that was one of the big reasons why you didn't see many companies come on chain, like many many apps got built. Because if you're a company, you cannot come on chain because there's problems regarding compliance. Now we're starting to solve that. The US is getting more and more open. More and more countries are adopting crypto, so this is getting solved. You cannot come on chain because there's low amount of security. There's hacks all the time. That's really dangerous for your company. So that was one thing. It was very slow and it was very costly. That was another thing. And then it was not private. And so all these companies couldn't come on chain because basically if you make a strategic investment, it's public. If you make payroll, it's totally public, and that's most
Everyone knows
usually
how much you're paying your employees. Yeah.
yeah, it's dangerous. And just like, and then so you have all these problems that just companies cannot accept to go on chain right now. And then even for users, then we're always saying this thing like, oh, the next billion users on the blockchain and yada yada yada. But that's the worst idea ever. Like imagine if I use blockchain every single day, then what would happen is that you can literally see a track record of every single payment that I've done in my life, like where I live, how much I earn, where my kids go to school, like and maybe I don't have anything to hide, but it's just for my security, I don't want this.
Yeah.
And so for me, security, privacy, and scalability were the three very big things that we had to solve to be able to firstly bring companies and then users on chain. Because in my opinion, how do you grow any ecosystem? You bring companies, you bring entrepreneurs, you bring builders, they build apps that people want to use, and then these are the things that bring the users. Users don't want to use a protocol. Users want to use apps, Facebook, Instagram, Revolut, Cash App, Venmo, PayPal, whatever. They want to use apps. They don't want to go on Ethereum and make transfers. No, they want a nice user interface, something that is usable, something that they like, that they derive value from. So create, and I'll finish on that. I think that Miden really solves the three key things that was preventing institutionals and big companies from coming on the blockchain, which is security, scalability, and privacy. And thanks to that, these institutionals, these big companies will be able to come on chain, create these protocols, create these apps, and then this will bring mass adoption of users on chain. And so I think it's going to be a new paradigm, and I'm super excited for that.
That's awesome. I really like that. But it sounds like your focus might be or like is going to be looking at big companies and showing them how to use this technology to build new features for their apps, for example, and less so the thing that people are more used to in the industry, which is just like hackathons, builder grants, like grassrootsy kind of stuff. And you're thinking, if we want a lot of users on this, we need to go to the big companies that have the firepower to develop like a good user experience that we can enable.
Yeah, I think we have a little bit of a different vision of how we can build something that is successful. I think that we've built blockchains for many years, and what is frustrating is that we don't find PMF. Like there are some things that are interesting, like real world assets or DeFi or stuff like that that are usable and valuable, or transfers of stable currencies and stuff like that, like cross-border payments. You can say that these are very good use cases, but in my opinion, it's not enough. Like we can do better, and we didn't find a way to unlock these millions or billions of users that could derive value from the blockchain, even though they could, but they can't right now because there's nothing, like there's no apps that they could use. There's nothing for them to do. And so yeah, we really want to focus not really anymore on hackathon style things. We really want to focus on people building real stuff, people building companies, people building products, people building apps for the masses, so the masses can derive value from it. And we're having a program on Miden that's called the Pioneer Program. And if anybody's interested, I'm very happy to talk to them in DMs. But basically, the idea is if you have a company, if you have a team of people or serious that have a track record, if you built interesting stuff in Web 2 or in Web 3 on other chains and stuff like that, we'd be glad to talk with you. And our goal is to onboard you to Miden, give you all the technical support, give you financial support, give you business support, and to push you to build a company on top of Miden. And so we're seeking for people with experience, some people that have the firepower, as you said, to build these very interesting apps that leverage the new capabilities or the new features that Miden brings, like security, scalability, and privacy, to build this next generation of applications on top of blockchain.
You're making my job so easy because everything that I thought I'm going to ask you to talk about, you're just going for it. So everyone listening in, you know, no, it's perfect. This is like, I love it. Normally I'm the one rambling on, so I love chatting. You know, I feel like everyone I bring on to this is very passionate and is working on really, really cool things. So I just got to sit here and listen and learn, which is awesome. But anybody who is interested in building on Miden, you heard it here from Paul Henry. You know who to talk to if you want to build some cool apps. So I don't want to keep you too long, but I wanted to maybe close off asking about timelines and stuff. I don't know if you have an answer for this, you know, like when mainnet, people love to ask this. I get, you know, people ask us this when we've already been on mainnet for a few months. But I'm curious to maybe close off hearing like what still needs to be done to get you from your current testnet state to something that is mainnet production grade. People are bridging assets. There's maybe real value locked into your chain. What needs to be done?
Yeah. So there's a few things that still need to be done. First, what we want to do is to be able to launch with a few protocols that are well built, audited, established, and even Miden needs to be audited and stuff like that still. So we need to do this. We need to finalize building some protocols. So we're already working with some pioneers, as I said, some pretty experienced teams that are building some things like DeFi primitives, like dark pools, order books, AMMs, oracles, and stuff like that. But we're really glad to talk to any other teams that would like to build in Miden. So we already have that, but then we need to finalize the implementations, do the audits of these protocols, and we want to have something really solid before launching mainnet. And then in terms of technicalities, we still have some parts of the protocol we need to finalize. So for example, we don't have the fee model yet. So we need to finalize the fee model because it's a little bit harder to think about the fee model in the sense that you have off-chain computation now, client-side execution improving. So that must be a way cheaper transaction if you do all the work than if you ask the blockchain to do the work and to execute. And then Miden, the blockchain can execute, but also you can execute. So you have different fee models for different types of transactions. So it's a little bit more complex, and we need to think about that. So there's the fee model. There's encrypted notes. So the fact that you're able to send a note to another user using encryption on the chain. And we also need to finalize the bridge. So we're working, for example, with Polygon and the AG layer and the LXLY bridge to be able to implement that for bridging on Miden. So there's a few components that are still to be done, but we're going really, really fast towards mainnet, which is really cool. So to give you an idea of that, we've been in testnet for, let's say, about 6 months now. We're planning to still be in testnets that are getting better and better every single month with every single release. I think for the next 6 months, and then we're slowly going to ramp up towards mainnet. So the idea, end of 2025, start of 2026, starting to ramp up towards mainnet. So that's what I would say. So around
so exciting.
2026, we should definitely be in mainnet. So that's
awesome.
That's very exciting, and I think it also leaves time for people to build still. So we're super early. If you're excited, join us. Like, let's build.
Still early, man. That is really cool. I think I could sit here asking you questions for hours because I still want to wrap my head around how like a lending protocol could work. Say there's, you do some stuff. We'll save it for another time, but I'm gonna
ask me. I'll answer it.
Okay. Okay. Let's. Yeah. Okay. Well, I don't want to keep you too long, but I am still trying to wrap my head around like that. Like if you have private state that may change, that may have some bearing on what's happening in the public state, right? Like, say the lending protocol goes to liquidate you because the assets that you supplied, that you have as collateral, fell in value, and now, I mean, I guess that state would be public if you have sufficient assets that would be liquidated. I'm trying to think like if there's a situation where they would need to know your private state that has changed. It's almost like a double spend problem. Like I again have not thought about it in too much depth,
No,
but I just thought of while you're discussing. Yeah, like not spending all day on this, but yeah, like there must be a nice, elegant solution there. Maybe it's not an issue at all, and I'm misunderstanding something. But
no, it's very good. If you have the question, I'm sure other people in the audience might also have it. So I think it's really good. I'm the number one of asking stupid questions. I think that's how you learn how you understand things.
I agree.
This is not a stupid question, actually. So how would that work? Let's say you have something like Aave on Miden. So basically, you would have this public contract that is deployed on chain, and that is a lending protocol. Then you have users that have off-chain private states. And so I'm a user of the Miden blockchain. I want to interact with Aave. I want to provide liquidity to Aave, and then I want to make a loan, for example. So I want to provide 10 ETH. So I take my state, I transition my state from a state where I have 10 ETH to a state where I have 0 ETH. So I use the Miden VM locally. So all of this will be in the Miden wallet. You don't need to think about it, but I'll just click on my Miden wallet. It will execute the transaction that will decrease my state and create this note. It will create a note with 10 ETH, and this note will be directed to the Aave protocol. It will send this note to the Aave protocol. So the Aave protocol will see that it receives a note with 10 ETH, but it won't know that it comes from me. But also on this note, I can make sure that the Aave protocol will be able to consume these ETH, but also will store them, for example, in another node inside the protocol. But this node will only be reconsumable by me, or something like that. And so what I mean by that is that I will send this 10 ETH to Aave. Aave will receive this 10 ETH. I will be able to borrow some BTC, for example, from Aave. And so I will click on the button borrow. Aave will create a note for me. I will be able to pull down the note to consume the note. And so all of this, I was able to lend privately and to borrow privately. So this is the first thing. But then now, if they need to liquidate me, the money is not in my state anymore. The money is on the Aave contract.
State.
So it's on the public state. But nobody knows that I interacted, or nobody knows that it's my position. But this money is on chain, so it can be accessed or it can be liquidated by someone. And so there's no problem with that. Maybe one thing to clarify that I maybe didn't talk about is how assets are managed on Miden. So on Miden, you don't have concepts of ERC20s, ERC721, ERC1155, I think, native assets. So on Ethereum, you have all these standards, and you also have ETH, which is the native asset. And so all the ERC20s and stuff like that, they're handled in contracts. So you're actually not sending anything to anyone. It's just you're updating a mapping in the contract, and then your wallet will pull down the information from the contract and will tell you, oh, you have this much, but you don't actually have this much in your account. It's just in the contract. Right? Yep. In Miden, it's totally different because every single asset is a native asset. So we have a concept of what we call a faucet account. That is an account that is able to generate assets. And then the faucet account generates some notes containing the assets. For example, there's the USDC faucet that is handled by the USDC company, by Circle. You deposit 10 euros or $10 to Circle. They generate a note for you for 10 USDC. And then the assets are not in the mapping somewhere or in the contract. They're actually in the note. And then when you consume this note, these assets are not in the mapping or somewhere, or not in the note anymore. They're actually in your account. So these assets, they don't live anywhere else than in your account. So now when you're going to transition your account, if you want to deposit these assets on Aave, then you will take these assets out of your account and put them and move them into a node, send them to Aave, and then Aave will consume this node and move these assets from the node to its vault or whatever.
Sorry to interrupt. This is interesting because it's, one of the things that I wouldn't say blew my mind, but one of the very interesting things that I like to explain to people is the account model that Ethereum has, where it's like you have a wallet, but it's not actually holding something. It's not like you have like tokens inside your wallet. It's just that they are assigned to your account and they show up in your wallet, and you can use the public-private key pair to make transactions happen. Whereas in Miden, it's almost like it is that misconception use case where the account actually is storing the assets, and it's not just controlling an address. Yeah,
Exactly. So
cool.
in Miden, we really simplify this model and we really secure things because now there's no more smart contract risk. There's no more whatever. It's your assets. These assets, you store them in your own state, or each account stores them in their state. So each asset in Miden is native and is moved between accounts using nodes, using these messages, as we said in the actor model. So I think it's a way more sane model, but it's also a way more efficient model also
Mm-hmm.
in different ways.
In terms of, you mentioned native assets, so I know you've already said that you're still figuring out the fee model, but will you be using ETH for gas? Is this something that's being designed right now?
Yeah, that's a great question. And that's the beauty of it. Like, as we said, um, you're it's really flexible because we have full account abstraction. So all the accounts are smart contracts, which
Mm,
means that if you want to pay fees in DAI or USDC or ETH or Shiba Inu, then I don't really mind. Imagine if I am the sequencer that will sequence your transaction. So at first, Miden will have only one sequencer. But in the future, we will decentralize and we'll have multiple sequencers. But the thing is, like, the sequencer can accept any type of asset. If I want, I can say that I can accept these three assets, for example, or I can say you can say in your smart contract directly that you will swap this asset for the actual asset that will be used as gas token if we have a specific gas token. But that's the beauty of programmability, that you have the ability to also pay the gas in any token. And we really want to push that forward. This idea of flexibility and the ability to not be bounded to any gas token anymore.
yeah,
Like this UX on Ethereum or
mm,
other chains is horrible.
yeah.
Let's use that.
I guess Miden itself will still need to pay Ethereum and ETH for all the roll-up stuff, right? But everyone within Miden has flexibility. That's really cool. One more question, last one. We
Shoot.
already talked about state being stored locally, privately amongst the different user devices during client-side proving. What about Miden itself? What about for the main Miden DA layer or data layer? Are you using Ethereum, using blobs, using some alt DA? How have you approached this design question?
Yeah, that's a very good question. So to give you the idea of the architecture of Miden, of the pyramid, basically it's like each user stores their state locally. And then each user generates local state transitions. And then these state transitions are sent to the blockchain. The blockchain verifies these state transitions. And then we aggregate these state transitions into batches. We recursively prove these batches. We aggregate these batches into blocks. We recursively prove these blocks. We aggregate these blocks into epochs. We recursively prove these epochs. And then most likely that's the moment we also post, for example, an epoch proof on Ethereum or on any other system, could even be aligned or whatever. Yeah, let's go aligned. It's important to be aligned, very important to be aligned. And so basically that's the moment we post our proof. So we have this pyramid where we aggregate things at multiple levels.
Yep.
Exactly. And so after that, we can pretty much do whatever we want with the data and the proof. So use a DA layer that could be Ethereum. So for settlement, we could, for example, use Ethereum, and for DA, we could use Ethereum. We could, for settlement, we could use a aligned layer, and then for DA, use Ethereum, or for DA, use Celestia, or for DA, use EigenDA, or for DA, use there's multiple solutions today. For settlement, we could use Ag layer. For settlement, maybe soon we could use Bitcoin, and for DA, we could use Bitcoin too. There's many different solutions. These things are not set in stone, and these things are not fully fleshed out yet. But they will be very soon, especially when we get the bridge and stuff like that finalized. We'll have answers to all these things.
Gotcha.
But that's what is good, I think, is that all these things are getting commoditized, which means that it's not really a problem anymore, because we have this flexibility of being able to choose.
Yeah,
The luxury
that's
of being able to choose.
super cool. I gotta go read your docs and blog posts, and I'm getting nerd psyched here, and I'm excited to dig into this and send you some questions by DMs. Because now I'm thinking, okay, what about interoperability? You know, choice of DA layer, if there's some shared sequencing or composability layer for you know, pre-confirmations now that'll influence the design decisions. But we could be here for hours, so
Yeah, there's one link that I really recommend you to go check out. It's
Okay.
a repo called awesome-miden. So maybe I can try to share very quickly.
Yeah, I think yeah. We can even just drop it into the chat on, where is this? We can just put it into the comments for people who.
Yeah,
Where
I sent
are
it
we? Oh,
on
geez.
the. I sent it to you on
StreamYard.
the chat. Yeah.
I
So
lost
basically, it's
the window. Where are we? Sorry. I have too many tabs and windows. There we go. Okay, I'm back. Okay, this here, awesome-miden, sweet. I'm gonna put this onto I dropped it into the chat for the actual stream.
nice. Yeah, and basically it's a link where you can find all the other links of Miden. So there you can find everything about Miden. So it's like an
Awesome.
aggregator of all our links. So our website, our organization repo, our playgrounds, our tutorials, our Twitter, our Telegram, but also all our documentation, our tooling, our research papers, all of our blog posts, our videos at different conferences. So there's a lot of resources. There's a lot of things you can learn about Miden, and I'm really evangelizing because, as you can see, I think I'm very interested and very passionate about it, and I want a lot more people to know about Miden and to start building on Miden. And there's actually starting to get some pretty cool stuff. So I really advise you, if you're getting Nerd Snipe, go check out the link.
Dude, I'm excited to dig into this, and I think the team has picked the right person to be leading DevRel, because you are definitely passionate, and I learned a lot today, dude. This is awesome, and I'm excited. So with that, for people listening who are in the Aligned Telegram or Discord, I'll share this link in there as well after we finish. If people want to reach out to you, how should they?
So my name is PHK Live everywhere. So on Twitter, you can DM me, or on Telegram, or on GitHub, or whatever. Just find a way to contact me. Paul Henry Cashfast, PHKLIVE, all stuck together. Just hit me up, and I will be glad to talk to you about Miden, talk to you about whatever, or onboard you on Miden. I think there's some pretty cool stuff to be built, and yeah, let's build.
It sounds like there definitely is. All right, Paul Henry, thank you again, my friend. This was a pleasure. Sad I won't be seeing you next weekend, but I'm sure I will before long. So have a great rest of your day. And yeah, thanks again.
It was a pleasure. Very good. Thank you so much.
Come back anytime. And the stream